Thank you so much for having me. My name is Sneha Ganguly, and I have come all the way from New York City. I wanted to be here in person and to be part of your club. I actually haven't done a lot of traveling and foraging, so I'm really excited to be here and to be able to join the walk this morning. Serenella, thank you so much for this opportunity.
Thank you.
And just to introduce the topic of the day, foray into fungal pigments. And much like a foray, we're going to scroll about and explore some notable mushrooms that give us pigments. And yeah, I will introduce myself shortly. I have in the background one of my favorite kinds of fungi, which is a spalting mushroom. And this is a box elder. And sometimes when you cut into it, it produces these bright red flaming spells and colors. Okay, so I'm controlling.
Yes. Arrow down brings you forward, up takes you back.
Yes.
What color is that? Which fungus?
Okay, so I think the box elder itself, when it is decaying, will do that. But I think there is also some kind of association with an insect as well. So there's a lot going on. I don't know the science. This is like a cross section that a friend of mine who is an arborist gave to me recently. So I was excited to share it with you all. Before we begin, I also just want to preface my talk and say I'm not a scientist, I am an artist. So today's conversation will probably be a little bit more artful than you're used to. But
See, the public likes it. They like it.
Okay, perfect. I did bring a small binder full of swatches and some examples that are not as precious to me, but I think will give you an idea of what I do. So if you're very, very careful, I will pass this around and you can enjoy it while I speak. Just promise me not to turn this upside down so everything falls out. So what you'll find is in the first sleeve are some swatches that are dyed with fungi and lichens, and I'll talk a little bit about them throughout the presentation. This is just an example of a silk painting I did with some mushroom spores, which I turned into alcohol inks, and I steam set. And then you have a number of examples of mushroom papers, mostly all wild forage mushrooms that I make into pulp and then I pour or pull into paper. So if you're really careful, you can flip through everything. Nothing is properly labeled, so you can ask me about what you want later. Okay. All right. So quickly, the agenda for this talk. Tom already pointed you to the chaga tea that I prepared, and I'll talk about it in the next slide. Then we're gonna just quickly touch on some fungal pigment basics. And then I think it's really important to talk about natural dyeing so you can better understand how pigments turn into dyes and inks and so on. And then we'll touch on melanin, chlorosiboria, my favorite fungi. We'll kind of touch on UV and bioluminescence and lichen as well. And again, it's just going to be sometimes, yeah, all different kinds of topics. So, all right. So the reason I wanted to prepare some chaga tea for you is because chaga is one of the densest forms of melanin that you can find in nature. And I thought it would be a beautiful way to sort of drink the pigments before we, prime you for this conversation. And this is something that I harvested this past winter in the Hudson Valley and Western Massachusetts. So for those of you who haven't tasted chaga tea, I thought it would be a nice treat. And of course, here is a slew of medicinal benefits. I also brought Roy Rogers' medicinal mushroom book. So if you're curious about what are the components and compounds in the chaga, please feel free to do so. So yeah. Okay, so My name is Sneha, but I also go by my alter ego, Kali Mushrooms. Um, as I said, I'm a visual artist, so when I sign off on my art, I use my moniker, Kali Mushrooms. And the reason why I'm so energized by the name Kali Mushrooms is because it embodies the Hindu goddess of death and rebirth, Kali. And why do I use her? The etymology of the word Kali means black. It means death and rebirth. It means time. And it also means ink. And so these are kind of all the aspects that I think inform my practice. And then the other reason, as an Indian woman, I'm proud of my cultural heritage. And I feel like within the mycological space, it can be very scientific. So my practice sort of elevates the more cultural aspects of mycology. You're seeing some of my mushroom paper, but usually I'll take those mushroom paper sheets and I'll collage them. And this is sort of a good example of my aesthetic. This is one of my first mushroom paper pieces. And this is actually this won a NAMA award one of the years for the Fungal art contest. I used the Asterium to actually make the paper. I also actually use some blood and I juxtapose it to show our close ancestry and also to embed my biology. And so I'm really interested in bioart and all this kind of some up and coming interests. And then I guess one interesting story about this, I kind of stylized these vultures. And this is inspired by another community that I'm a part of, the POC fungi community. And on a walk, somebody mentioned, it's a little bit, to call something the false of something else is really not venerating its essence. And so someone kind of said, oh, well, why don't we call the Asterium or the false turkey tail the vulture tail? And so this moment of I guess renaming this common name that we use. Yeah. Okay, little bit more about, sorry. So in New York, I do a couple of things in the realm of mushrooms. First and foremost, I am a member of the New York Mycological Society. I'm best known for ushering in New York City's first ever public fungus festival in 2022. When, if you guys know Sigrid Jacob, she was like my partner in crime in doing that.
Mm-hmm.
It's going to happen again this year. So if you guys want to make a trip to New York on October 5th, let me know. I'll be happy to not hosting, but at least be your point of contact there. I also teach online courses for Cornell Small Farms. It's sort of like an extension program within the Cal's agricultural school, mostly for small farmers, educators, community organizers, and soon one of our courses is going to begin. So if you're interested in that, those are really great. And then last but not least, I see that there is a strong interest in cultivation in your club. So this is a new effort, and we're working on the name, the New York NYC Mushroom Network. And we are a coalition of members and organizations, and our mission is to upcycle plant and wood waste from our urban forest and expand mushroom cultivation throughout the city in community gardens and green spaces. We kind of want to broker between, the arborists and parks workers, and oftentimes we see all this pruned wood go to waste, be mulched, and we see a real opportunity to kind of connect these threads and create this like circular agricultural system. Cool. Okay. Finally, fungal pigments. So I guess this slide just summarizes some of, some things that I come across about the function of fungal pigments. First and foremost, throughout the literature, Oftentimes, fungal pigments, the function of fungal pigments is to endure abiotic stress. This could be, of course, maybe radiation, climate, maybe the lack of water or nutrition that might help, that might determine the pigment of a mushroom. Also, as you know, for drinking chaga tea, these pigments also have medicinal properties, and that could be another reason for them to embody the color that they do. Also, species-specific colors and environmental conditions. So I wanted to illustrate this point. I went on the pet foray last year, and within the hollow of this giant oak tree, we came across this like albino looking mushroom. And this is actually a maitake. It hasn't seen the light of day. And the same maitake is growing outside, and it looks like it you would find and that you might recognize. And so just kind of showing you know, how these colors are produced. And then last but not least, pigments change based on age, and yeah, so these are just summarizing the function of fungal pigments. Before we dive into some dye materials using mushroom fruiting bodies, I thought it would be interesting to just consider some other aspects of mushrooms that could provide pigments or are pigmented. As you see, this is like the purple puffball mushroom, and I learned about the pigskin puffball being poisonous. Now I'm a little weary about working with these puffball mushrooms because who knows? But I just kind of want to show this is a collection of the Calvaceous cyanidiflora spores. These were bottled at the same time, and the only difference, this is like the same from the same organism. The only difference between these two is this one is hydrated. This one has water inside, and this one does not. So you can see the one without the water has lost its color, and the one that has been hydrated is still purple. So I think puffballs are a really unique and interesting mushroom that is sort of understudied, and they go through a lot of kind of unique cycles in the fungal world. Also, spores are hydrophobic, so probably will not find a lot of success when you're dyeing with them. But if you're curious to experiment with spores and pigments, I recommend that you mix it with alcohol and you make an alcohol ink. And that could, you know, that will, of course, then, yeah, be able to make a solution that you can apply. Another opportunity for fungal pigments, and this I find really magical. So this is Lactifluus bolemus. As you know, the latex of Lactarius and Lactifluus can be a key identification marker. And what is unique about this one is I actually take the milky exudate and I just simply take a paintbrush and I apply it on my mushroom paper. And this brown stain is actually the fungal latex. So yeah, that could be.
Is the paper paper you made, like it has a special chemical?
There's no special chemical on this paper, but it is paper made out of mushrooms. So however, I think that it can stain other things as well. So I've tried this with the indigo, and I can stain, you know, one sheet of copy paper or something like that. There's a lot to kind of explore and experiment with. A lot of the work I'll share today is going to be anecdotal.
You have to do something from fading, or is it?
Not at all.
Color?
It holds the color, surprisingly. But I guess that's the other thing that really excites me about my work. You know, I work as an artist in the art market. We're so hyper obsessed with things that last forever. And I kind of love that fungi really challenge those making and collecting practices and saying, you know, I have a life cycle and I might not be archival. And I think those things really excite me.
I have a basket and was showing somebody and it dripped on the handle of the bath. It's still stained to this.
Yeah. So again, like I think these are moments that happen that we really know nothing about and I think are definitely worth exploring both artistically and scientifically. Okay, so stains could be another opportunity for pigments, staining. So here you see a black staining polypore. What I find really unique about this is the black stain is from it melanating, and melanin is insoluble, and it's usually not something that you can dye with. But here I use a fermentation method on just a cotton t-shirt. And you just kind of take the polypore and you just nestle it and you bundle it and you leave it to ferment and decay, nothing really that special. And it does transfer and leave its pigment onto the shirt. So I thought this was a really interesting moment that utilized fermentation. Okay, and then just reagents. Today, I think on the walk, we may have stumbled upon some Haplophilus nigellans. So reagents might be a good way to explore pigments as they kind of shift the pH of the mushroom. Here you can see with a little bit of a KOH test that it turns this mushroom bright purple. This color also can be fast to textiles and be applied as ink as well. So
That is wild.
yeah, it's
Wow.
bright. Okay, so a quick introduction to natural dyeing with mushrooms. Just a quick, some hands. Who knows anything about natural dyeing or natural dyeing with mushrooms? And who's, okay, cool. And who's brand new to the topic? Okay, 50-50, cool. All right, so how do you figure out that something has pigments? So the quickest way that you can test for pigment potential is you just take the piece of mushroom and with some boiling water, you just pour it over a small piece. And usually if it kind of emits or of some color, that could maybe potentially be a pigment that you could dye with. So here's just a collection of some dried mushrooms. Again, some mushrooms need to be used fresh. For example, the coral mushroom, if you use it immediately and fresh, can give you a soft purple lilac color. And I'll show you in the next slide of something that prefers to be more rotten, more oxidized. Also, the different parts of the mushrooms retain different, amounts of pigment. So the stem might be different from the cap. Sometimes you might want to use them together. Sometimes you might want to separate them. So there's so many nuances to dyeing with fungi. It really depends on the species that you're working with and the way that it likes to be treated. So yeah, an example of a mushroom that is better off, does better when it's decayed is Hydnella. And Hydnella produces these beautiful blue colors, always so exciting. On the left-hand side is a silk painting made with all fungal pigments. The sky is painted with Hydnella. And so for Hydnella, what you want to do, if you take it straight to the dye pot, you're not going to achieve this blue color. It actually needs to sit in water overnight. And then the pH needs to be increased like to 10, 12, 13. And then when you dye with it, when you decoct it in a water bath, it will give you a blue pigment. So without taking that extra step, it will just be this kind of brown color. So there's something about oxidizing this particular mushroom that really helps extract this blue from it. I guess I will just say one more thing. I often work with silks. One, because fungal pigments do better and fast better to protein fibers. So wool and silk. And I kind of also love like the metaphor, you know, I love how the fungi kind of bites into these like animal proteins as compared to like the synthetic, like cotton or something else. And if you look at silk or wool under a microscope, it just is a lot kinkier than other synthetic fibers. And so there are a lot of sites for the pigment to deposit. And that's one of the reasons why it does so well. And as a Indian woman, I want to kind of again carry on my cultural heritage, and we are known for our color textile science and you know, gorgeous saris and dyeing. And so this is just my way of sort of carrying that on, but in you know, kind of introducing it to my other passion, which is mushrooms.
Theme of that art form,
Theme.
right there, exactly.
The theme, okay, so it's just two sisters and they're sitting under a tree. The tree that's like branching over them or under them. And you know, it kind of reminded me of like the bodhisattva sitting under the tree meditating. But here you have like two sisters and they're looking at this fruit and kind of just pondering it. Could be the fruit from the tree, could be the mushroom. Yeah, there's no real meaning. Just probably something I had a vision of that I illustrated. But yes, oftentimes I will illustrate kind of my learnings from the forest or the natural world. The bottom is Pissolithus. Actually, the sun on the left is probably chanterelle,
Oh,
as it creates this very light buttery yellow. And then yeah, I think inky cap. I think the green, yeah, escapes me, but yeah, I have a label somewhere. Okay, so very quickly, the steps of natural dyeing. Again, I think it's really important to talk about this so that you can understand what pigments are and what dyes are. So let me start there. How does a pigment turn into a dye? Usually, let's say you have a pigment, you have some kind of organism that you're using for pigment, and you want to turn that into a dye and you want to fix it onto a textile. You need to pre-prepare the textile with a metallic salt, and then through heat, it can then kind of take the pigment and permanently fix it onto the textile. And we're going to go through how to do that, but that is essentially how a pigment turns into a dye and ionizes and becomes like the textile. So the first step is to scour your textile, which is simply to wash it. Usually when you receive some silk, usually has a lot of residue, even though it might look clean. You don't want that there because then the pigment is going to attach to that residue and not the textile itself and kind of produce this splotchy color or effect. You want to use like a mild detergent, and just here are some steps. So 1% of the weight of fiber, and then I bring that to a boil, and I look for shrimp eyes, which is about 140, 150 degrees. I don't want to degrade the silk or the softness of the silk. And then I gently will simmer it after bringing it to a boil for 30 minutes. Then you want to mortar it. Like I said, this is probably the most important step of taking a pigment and turning it into a permanent dye. You want to use a metallic salt to pre-prepare your textile. I have some ratios and recipes for you. 1 ounce of fiber calls for 0.75 teaspoon of alum. So what is a metallic salt? We're either using potassium aluminum sulfate or ferrous sulfate. There are a lot of other metallic salts like copper, zinc, and tin, but they are far more toxic than something like alum. Alum you can actually sometimes find at the grocery store in the pickling section or in the seasoning section. So in small quantities is not toxic and is food safe. So That's the one that's recommended, alum. So you just want to add it to some hot water, and then you want to bring it to a boil, and you want to put it to the simmer, and then you want to soak your textile in that. And what I personally like to do is I like to more it into the evening, and then I like to leave it in the dye pot and then take it out the next day. I just find that then there's like, I know for sure that the mordant has applied to the textile properly and well.
How many colors are you able to extract? We have a whole spectrum of colors.
All the colors are definitely possible. Yeah, I don't know if you noticed in the book, but I think all the colors are represented. Okay, last but not least, then you want to weigh out your mushrooms. A 1-to-1 ratio is good, or a 2-to-1 ratio when you're working with fresh mushrooms is good. What you want to do is you want to, once again, bring your dye pot to a boil. You want to simmer it for at least 1 hour to extract as much pigment as you can. Most mushrooms, I think if you keep steeping it and you keep extracting the pigment from the mushroom, will only make the dye pot richer. But there are some mushrooms, say the lobster mushroom, I think if you overheat it, you'll kind of lose that golden quality. So I don't have a hard and fast rule for how long. Again, it really depends on the mushroom that you're working with. It's all like being treated slightly differently. Yeah, so you bring it to a boil, you let it simmer, and then once you have the dye pot, you can actually add the fabric. You could take it off the heat and add the fabric, or you can put the fabric in while it's very gently low simmer. And then I guess I can go to the next slide. Another way that you can achieve multiple colors from one single mushroom, and I will show you some examples of that, is to modify the pH balance of your solution, or your dye bath. You can do that. So for those of you who are familiar with the pH scale, so a 7 is neutral. And if we want to increase the acidity, we could use things like lemons or vinegar, all usually readily available at home. And then if you want to increase the alkalinity of something, so increase the pH number, you could use things like ammonia or wood ash lye or baking soda, washing soda, potassium carbonate. Yeah. And it's really easy to make iron water. It's 1 part vinegar, 1 part water, and a bunch of rusty nails. So I love to do things all DIY. And this is a beautiful mushroom workshop I did at the Noguchi Museum for a bunch of Spanish speakers. Okay, so some examples of mushroom dyes. I think this is actually not very well known, but cordyceps mushrooms, even though highly medicinal to us, can also produce this beautiful golden color. The only thing about how you achieve that is by using increasing the alkalinity, and I do so with some potassium carbonate. And I just wanted to, we didn't talk about subcellus. I don't know if I would say. Yeah, okay. I also wanted to acknowledge that, of course, the cordyceps mushroom is highly medicinal to us, but it's also being explored for organ transplantation. And apparently, it will sort of try to curb the infection or any infections that may arise from surgical transplantation. I just thought it was like a great mushroom that is cultivated, has medicinal benefits, but also color. Another common mushroom that goes a really long way is Pisolithus and dead man's foot. This turd-looking mushroom produces this beautiful chocolatey color. And here you see an example. I think it's really subtle, but at the very top is what you would get if you just steep it in the dye bath without shifting its pH. However, if you increase if you decrease the pH when you do an acidic shift, you get this sort of chocolatey color, right? Maybe more of an auburn. Maybe we can get our color words out today. And then on the left, if you do an alkaline shift, it produces this gorgeous purple hue on top of the brown. So again, same mushroom, but by shifting the pH, you can gain multiple colors.
What's in the center?
Look like it. I will get to that. Okay, so Cortinarius semi-sanguineus, often found in the Pinelands in New Jersey, and also one of the few mushrooms that produces this bright red color. And here you see another example. I don't know if it's really apparent on the screen, but with an acidic shift, you get some more orange tones, and with an alkaline shift, you get these like deep rosy red color. And then you can add the iron mordant, or if you modify it with iron, it's what we call, it saddens the color. So you get these sort of darker colors by adding the iron. Hypomycete is lobster mushroom, the fungus that's parasitizing Lactarius or the Russula or whatever it is underneath there. This like beautiful bright orange coating is where you get this gorgeous dye. When you first dye with it, you're gonna get this beautiful orange yellow color. And when you do an alkaline shift, when you increase the pH, it produces these beautiful pink purple hues. So yeah, this is one example of multiple colors from one mushroom.
Must the mushroom be in a certain qualitative state, or can you get a decaying one as well?
That's the thing, I can't sort of say, it depends on the mushroom. So I would say you should probably study your pigment mushrooms before you go into the forest, but also when you find something that you come across, you can do a little pigment test and see if there's any potential. And then of course, like diving into the literature and all the anecdotal like information that's online to see how to achieve these colors. They're all to be treated slightly different. Okay, so a few basics about fungal melanin. The melanin exists in all biological kingdoms. Melanin absorbs light across the visible and UV spectrum. It's insoluble and acid resistant. Like I said, it's really difficult to dye with, but had success with the fermentation method. We had wood-eater mushrooms for lunch. We didn't see any in the forest, but it's a great source of fungal melanin, and it's really great for heart health. Another something else that's made of fungal melanin is the corn smut mushroom, and so again, melanin is insoluble, so we don't actually extract any nutrition from it, but they have such a kind of a magical power. So they scavenge for free radicals in the body, and they are super high in antioxidants and of course like anti-cancer, anti-tumor. They protect fungi from radiation. Here I have an image from Chernobyl, which sort of kicked off the idea that fungi are using radiation to grow, to energize themselves. Also, a melanotic fungi, Cryomyces, was isolated in Antarctica, and that particular fungi is the one that was sent to the ISS. Another melanating fungi that's interesting to think about is Armillaria. As we know, it's one of the few melanized mycelium as well. It also just happens to be the largest organism, so there must be some association there that gives it that sort of rigor and advantage. I just wanted to also point out, I have an SEM photo of what melanin looks like under the scope. So it's these like these granular, they look granular and they're really difficult to destroy. What I thought was really cool. Yeah, another really great source of melanin is inky cap mushrooms. As you know, when they deliquesce and turn into black goo, yeah, they're just a bunch of spores. It's really easy to use them as an ink. I don't know how many of you have tried that. Yeah.
It's on our shirt too.
Oh, really?
Yeah,
Oh, wonderful.
I'm hoping, actually, if anyone finds some in the next few weeks, I'd love to have it at the mushroom fair.
Yeah. I do have to usually, like I said, spores don't do well. They're not really a great dye. But when I paint it on silk and I steam set it, it sets pretty well. But if you were to just like paint it on a piece of paper, over time, it would sort of dry out and probably a bunch of it would sort of kind of evaporate.
Mhm.
Yeah, adding the binder really helps.
Yeah, is that what you do?
Yes.
Yeah.
Well, I've only done it once, but I definitely added the binder, so
Yeah.
it wasn't gonna stay. But
Yeah, so I just made some suggestions on how you can process it. You can just use it like, just deliquesce it in a jar and then use it straight away. You can add different binders and experiment with it. You can thicken it by boiling it if you want to reach a certain viscosity. And then I really like to mix it with alcohol, isopropyl alcohol. I can paint with it on silk, and then again I can steam set it. So my favorite mushroom, Chloroceboria, the blue-green elf cup. So Chloroceboria is a salting fungi. Basically, as it's decomposing wood, it expresses a pigment. They're largely found on oak, but I've also found them on all kinds of wood. They are a brown rot fungi. So usually when you find them in the forest, they're on like extremely decayed wood debris. Pretty hard to, not hard, but it can be hard to kind of do any woodwork with them unless you find a piece that's not too decayed.
People also can stabilize those wood pieces in resin and then do woodwork with them.
Right. Absolutely. Here is an example of marquetry from Spain from the 1400s. There were a few examples from Spain, a few examples from Germany, and a few examples from Chile, but I couldn't quite find many images from the internet. So there's some that I had found in Dr. Siri Robinson's book, and I'm going to talk about her in just a moment. But here you can see the spalted wood has been used, and this is how many years old? This is like
Wow.
old, and the color is still bright and blue. So some of these pigments are truly color fast, and yeah. So if you're interested in spalting mushrooms, I recommend that you check out Northern Spalting. This is Dr. Siri Robinson's Fungal Pigment Lab at Oregon State University. I had the privilege of paying her a visit, and I like to joke that she's very laid back. Because as part of her courses, you can take wood turning with her, and she of course specializes in spalted wood. And if you're really into spalting mushrooms, you can join her Patreon. And if you pay a certain amount, she'll also actually send you cultures and chip plates, and give you access to some of their research. So most of the time, these pigments are extracted with these very like methylene chloride, shortened for DCM. Something that could be an alternative is acetone, which is peanut polish remover. But in the next few slides, I'm going to share a highly proprietary process of my own. And I have had success both extracting the pigment. I didn't even name the pigment. So the pigment was named in 2018. It's called xylidin, And I think they at my house at the conference today.
Okay.
Yeah, I don't want.
Recording resume.
And not pretty. Okay. Well, I did my best. I'm comfortable sharing out.
Thank you so much.
You're walking the woods, you come across this blue-green wood. Again, I love that. It kind of debunks this thing of like, there's no blue in nature, but I think it's such a beautiful example of blue-green in nature. Here I just kind of cut it in half with a small chainsaw and a nice little cross section. You can see the colors throughout the wood, not just, on the not superficial and just on the outside. Then I make a nice collection of all the wood. I will hydrate it. Okay, so my secret. I'll describe it. So the one ingredient that's missing from this image here is another mushroom. And I will say that it is a saprophytic mushroom. It's a Basidiomycete. And I think the reason why it is so good at helping extract this pigment into water or whatever solution. As you know, Basidiomycete have a lot of wood decaying compounds. So I have a feeling that it kind of helps that process. They have all these enzymes that are made to decay wood. Again, I don't know how interchangeable it is, but that's my secret.
Fair enough.
Go through until you determine that's the one.
It's neat. Oh, I can tell you that. Well, I think what I'm sharing is like, I think there could be a lot of mushrooms that could maybe work.
Right.
That's all I'll say.
Thank you.
No problem. So anyway, I'm soaking it in water for at least 24 hours. I'm breaking the cell walls and extracting the pigment into the water. Again, Dr. Siri Robinson is using all these sort of harsh solutions to do the same. And I'm using this mushroom that I think has these wood decaying enzymes to also help extract more pigments into the solution. Clearly it has worked. And then I take the pigment and I can apply it to my silk. I can make a glue stain onto wood. And it's pretty fast in the sense that, it doesn't transfer once you put it onto the wood, it's almost as if it was always there. And this is one of the methods to spalt things. Dr. Siri Robinson's book, Spalting 101, just talk about how you can grow spalted mushrooms onto wood and get these beautiful zone lines. But another alternative is to just create a beautiful stain. Yeah. So bioluminescence, fluorescence, again, these are mushrooms that emit light. Bioluminescence is like the light that emanates from within. And then fluorescence is a light through the shining UV light from onto it, and it then emanates this light. I won't say too much. I know Serenella, this is one of your specialties. But I will point out some interesting people within this space and some interesting happenings. On the right-hand side is a good friend of mine, Blackie, and this is the Omphaloma and jack-o'-lantern mushroom. It glows in the dark. And you find it on the West Coast. I don't know what the name is for the variety on the West Coast, but if you dye with it, also gives you a purple color. It's not the one that you find on the East Coast. Again, that would be a really interesting, same mushroom, different regions, different conditions, different species. One produces a dye, one does not. So I think that's another kind of interesting nuance. For those of you familiar with the Odin and are really into kind of DIY biotechnology, they're using Pinella stypticus to kind of create this concept of like a nightlight, which I thought was interesting. If you guys know, if you're in the world of fungal pigments, you might have come across Sydney over Singleton's work, and he's made henna out of dyer's polypore, and is also applying that to textiles. This is UV fluorescent, and I'm kind of imagining, you know, as we know, fluorescence has been really important in the sciences for microscopy, for DNA sequencing, as markers and so on. However, I'm imagining, you know, what do UV activated pigments, how can they be applied in our built environment or in our clothes or, yeah. And then light bio, I think, is, a petunia that's using the glowing genes of fireflies. And this is from Ginkgo Bioworks. They're up in Massachusetts. And yeah, they are genetically modifying things and making them glow. So this could be another opportunity. And we could be utilizing fungi instead of fireflies. So
And I'm gonna take 2 seconds to say that here, Jared Urchek has brought a plate of Panellus stypticus to see if we can have the experience of going in a closet and seeing it glow as soon as the presentation is over.
Jared Urchek has
Sorry.
PhD. We did bring some chicken of the woods and some UV, but I forgot the milk. Sorry.
Oh, okay.
well, the reason we did all that is because one of the mushrooms that is a really wonderful dyer and is also UV fluorescent is the dyer's polypore. A little bit goes a long way and produces this beautiful, rich golden color that gets nice and deep. And again, saggins with the iron into this dark green. As you know, they are sort of partial to conifers. And here you see an example of my mushroom paper. The raindrops are actually fireflies.
Aha.
Right? Oh, and it's supposed to be Pinellus stypticus. So, and this is a simple paper circuit on my mushroom paper. So it's actually, these LEDs are glowing and I use these conductive foil tape and some batteries are like kind of, yeah, really
So
elevate,
cute.
this concept.
It's gorgeous.
So I take a wash of this dyer's polypore and the raindrops are made of the same thing that the Pinellus here is made of. But I put a wash of the dyer's polypore on these mushrooms and you can see under UV, it glows. So I kind of just love that, you know, there's like this invisible pigment and then when you shine a UV light on it, it emerges, it reveals itself. Another great source for fungal pigments is lichen. Just like mushrooms, you could probably produce the whole rainbow using lichen. So this is wolf lichen, and it's sought after for its full sulfuric acid. On the bottom, you see some scientists at NASA holding it. They are exploring it for its UV properties. And so I collected some of it when I visited the West Coast. It's growing on ponderosa pines. It's super prevalent there. It's got this really distinctive lemon lime color. And is just an excellent dyer. It's been used, I think, as like a poison for keeping foxes and other animals away, or wolves away, thereby, you know, wolf lichen. Here is an example of some indigenous artwork. I think contemporary indigenous artwork from the Pacific Northwest. Again, this like beautiful lemon lime color has like an identity of its own. So when you see it, you kind of know it's the wolf lichen.
Fantastic.
This one is a little bit toxic, actually a lot of it toxic. So something that you should dye with outdoors. These are not fumes that you want to breathe in as you're dyeing. You don't want to hover over your dye pot and get a whiff of it. Yeah, so lichen dye. I'm not sure if you were working with Umbilicaria. Yeah, So this is also one of my favorite lichens to come across. It grows on rock faces, the rock tribe lichen. So what you want to do, lichens are not like mushrooms. You're not decocting it in a water bath. Usually people that are seeking red, purple colors from lichens will do like an ammonia test. And if the lichen where you dropped ammonia turns reddish, it could reveal that with the increase in alkalinity that it could shift to purple or red. So it's just like a test. And then to achieve this color, what I do is I take the potash ashes from a fire. I make wood ash lye. So in equal parts water and wood ash, and put it into a jar. And you can boil it, and then you will let it settle. You let the solution, and then you kind of let the debris kind of settle at the bottom, and then you're going to use this highly alkaline solution. You're going to add it to your umbilicaria. You want to probably break down the umbilicaria so it has more in smaller pieces, so the solution can penetrate it better. And then you want to put it all together in a jar. You want to ferment it. So you want to burp it every single day. You want to give it some air. You want to open up the jar, close it. You want to shake it every single day. And at least 3 weeks, but around 5 to 6 weeks, you will get this beautiful, rich purple color. The binder that's being passed around, I think, has a better, richer purple example. But as I think you mentioned on our walk, this is sort of a softer lilac color. Yeah, so that's sort of the spectrum of purples that you can achieve. Something about this color is that it's fugitive. So even though it's so beautiful now, it's not color fast or light fast. And over time, it is ephemeral and it's going to disappear. And if it is color fast, it's called substantive. Yeah, so I love these sort of alternative methods to natural dyeing. That concludes my presentation. I think the last slide are some resources. If you know about fungal pigments, you've probably already heard of all these folks on screen: Judy Wheeler, Mushroom Color Atlas, Lisa Allen, Pigments. She runs a beautiful Facebook group. Miriam C. Rice, of course, and then Mordier. Mordier lives. She's like one of my good friends and mentors. Carrie Lachance. She lives in Connecticut. Yeah. So that concludes my presentation.
Thank you. Wonderful. So, oh my God. So as a part of, anyway, we can just. So as a part of having the opportunity to have Sneha here, one very important aspect, I swear to God, I can project. Don't worry about it. Part of what's good about having Sneha here is having all of you have the opportunity to ask questions and interact with her, but also see some UV action as well.
Oh yes.
So this is a closet that you could go in with some mushrooms. I'm gonna go get from the fungarium a couple of rosulas so we can check that out as well. Those tend to be fluorescent, and please feel free to ask your questions to our speaker. Thank you so much. You have been so amazing. Thank you.
Mitch. Oh, but